Hello, welcome to Learn with Lakineni. Now we are coming with another subject, formal long base and automata theory. So this is a very important subject for computer science engineering students. So in GATE point of view also, this subject is very important. So keeping this point, we want to make videos on formal long base and automata theory from basic concepts to all the concepts in flat. And also we will solve various examples, and also we will solve GATE questions on formal long base and automata theory subject. So these videos will be helpful for any type of university student. We will clearly explain all the concepts and we will do more practical examples, and every example will be explained clearly with the solving capabilities for GATE examinations also. So please watch all these videos. Please subscribe to my channel, Learn with Lakineni. Please like it, share to your friends. Please watch all the videos. Thank you. Thank you for watching my videos. Formal long base and automata theory. This is a very beautiful and important subject for every computer science engineering student, because when we are designing some programming language, every programming language has some syntaxes. Every programming language has behind a compiler, interpreters. So when we are writing a program and when you are running the program, that means when you are compiling the program, if you have any errors in the program, compiler will show you the syntactical errors. How the compiler is able to show the syntactical errors? How the compiler is able to recognize the syntax errors in your program? There is a mechanism. How we are implementing the mechanism? So there is a concept behind every compiler. There is a concept behind every programming language called formal language and automata theory. Generally, formal language means we are speaking so many languages. We speak English, we speak Hindi, we speak Telugu. We'll have so many speaking languages, natural speaking languages. For the languages, we are following some grammar. With the help of grammar only, we are speaking the languages. Every sentence has a meaning because every sentence is following some grammar. So similarly, when we are preparing or when we are constructing a programming language, every programming language has to follow some grammar. With the help of grammar, we are able to construct a programming language. So that when you compile the program, your compiler will check whether you have written the program as per the grammar or not. Here the grammar is nothing but the syntax, a rule to be followed. For that, formal language and automata theory helps in designing the programming languages, in designing the compilers, in designing the lexical analyzers. So many applications are there with the formal language and automata theory. So we will discuss one by one clearly what is a formal languages, what is an automata theory, and how we can design automatas for different problems. What are the different formal languages are there? Who is the father of the formal languages? Noam Chomsky is the father of formal languages. He has created 4 languages. Like that, you have so many various automatas, construction of automatas. All this we'll discuss during the course of the entire syllabus. So, automata theory is a branch of theory of computation. It is a branch of theory of computation. It deals with the study of abstract machines and their capabilities for computation. That means an automata is a computational machine which takes the input and accordingly it changes its state, and finally it will halt, it will stay at some state. Then we decide whether the given language or the given string is acceptable string or not. That means the syntax is accepted or not. It is an abstract mission. That abstract mission we are designing and we are analyzing on various strings. So before knowing what is an automata, what is a mission, first of all we should know the fundamental concepts called what is a symbol, what is an alphabet, what is a string, what is a grammar, what is a language. So these things we have to know. Why? Because in the entire course of syllabus we need to speak about strings, symbols, alphabets, language, grammars. So that we have to know about all these fundamentals. So first of all, you just remember that an automata is a computational machine. We can call it the abstract computational machine, which takes the input and accordingly it changes its states and finally it will halt at some states. Then according to the final state, we will decide the acceptability of these strings, the acceptability of a language. So it's a very important subject in GATE point of view also. Formal language and automata theory is important. If you understand the concepts of flat very well, then it is easy to understand the concepts of compiler design. Here we will discuss various types of grammars, various types of automatas and their constructions with various examples and the equivalences, conversions from one automata to another automata, conversions from grammar to the automatas. We will discuss so many things in formal language and automata theory. So in this video, we are explaining what is an automata, what are the different fundamental concepts required for the automata. So only just remember that automata includes design and analysis, which are mathematical models that can perform computations on strings of symbols according to a set of rules. These rules is nothing but a grammar. Rule is nothing but a grammar. Set of strings will form a language. Set of strings will form a language. The main motivation behind developing the automata theory was to develop methods to describe and analyze the dynamic behavior of discrete systems. So this is the main motto of developing the automata theory. Every automata contains states and transition. States are represented by circles and the transitions are represented by arrows from one state to the another state. So automata is a kind of machine which takes some strings as inputs and this input goes through a finite number of states and may enter into the final state or may stop at any state. So based on this state, we will decide whether the string is accepted or not, whether the language is accepted or not. So this is what the introduction of what is an automata. You please simply think that an automata is a abstract mathematical computation machine through which we are supplying input and accordingly it changes the states and finally it will be halt or stop at some state. It may be a final state or it may be a non-final state. Accordingly, we will decide whether the string is accepted or not. So this is what about an automata. Now we will discuss the initial fundamental elements of formal language and automata theory. First of all, we should know what is an alphabet. An alphabet is a finite, non-empty set of symbols. Suppose if you take an English language, in English language we have 26 alphabets. 26 alphabets are 26 symbols. Suppose if you take, suppose here in English we have A to Z. So how many are there? There are 26 alphabets. 26 alphabets. 26 alphabets are 26 symbols. Symbols. A symbol means a sound. A symbol means it is a sound. So here there are 26 alpha symbols. This is called as alphabet. This is called as alphabet. Alphabet is denoted by sigma. Sigma. Sigma is equal to set of A, B, C, D, so on up to Z. So this is an alphabet. Alphabet means a set of symbols which we are using in that particular language. So when you are writing the words, when you are writing the sentences in English, we will use these symbols only. That means whatever the word you writing, we are writing all the characters, that means all the alphabets in that word will be from this alphabet only. We will not use any new alphabet. We will not use any new symbols. So entire English language, all the words we are designing from these 26 symbols only. So what is an alphabet? An alphabet is the fundamental unit in which the basic symbols will be there. With that help of symbols, we are going to form the strings. So alphabet means the symbols which we are using in a particular language. It may be a programming language or it may be a speaking language. In any language, you will have a fixed number of symbols. Those fixed number of symbols are called as alphabets. Similarly, in formal language and automated theory also, we have alphabet. Alphabet is nothing but a set of symbols which we are using in the particular language. Here, alphabet is a finite. Every time, alphabet consisting of only finite number of symbols only. It will never be an infinite. Non-empty set of symbols. Why it is non-empty? If it is a non-empty, then how can we form the strings? If you want to form a string, you need a set of characters. So you need a character. You need a symbol. If you don't have symbols, how can you form a string? So that's why always the alphabet is a non-empty set. It is denoted by universally, it is denoted by sigma. Let us suppose sigma is equal to 0, 1. What is this? It is a binary alphabet. Why? Because it consisting of only two symbols. It consisting of only two symbols, 0 and 1. So it is called as a binary alphabet. Suppose if you take sigma is equal to A, B, C, so on, Z. It is a lowercase English alphabet. It contains 26 symbols. That means 26 characters. So this is what is called the alphabet. From alphabet only, we are forming the strings. Without alphabet, we cannot form the strings. Suppose if we take power of an alphabet, that means power of an alphabet. Here I'll explain what is the power of an alphabet. Suppose if I have an alphabet, sigma is equal to 0, 1. Power of an alphabet means suppose sigma power 0. That means from the alphabet sigma, I want to form strings of size 0. Of size 0. That means the strings of length 0. The strings of length 0 means 0 length strings. So here the 0 length string in formal language automated theory is represented as epsilon. Epsilon indicates it is a 0 length string. So here if you want to form sigma power 0, that means sigma power 0 means 0 length strings. So here epsilon will be the 0 length string. Suppose if you want to form the strings of sigma power 1, that means of length 0, of length 1. So here the length 1 is 0 and 1. So 0 is of length 1 and 1 is of a string of length 1. Suppose if you take sigma power 2, that means we are forming the strings of length 0, length 2 from these two symbols. That means from this alphabet, I am forming the strings of length 2. Here, what are the combinations? 0, 0, which is a length 2, 0, 1, which is a length 2, 1, 0, which is a length 2, and 1, 1, which is a length 2. So, these are the 4 strings which I can form with the sigma power 2. So, like that, we can form any number of strings with a sigma power, or you can call it as a alphabet power. Suppose if you see, if sigma is an alphabet, we can express the set of strings of a certain length from the alphabet by using exponential notation. I already explained sigma power 0. So that is the length of 0. Sigma power 1. That means strings of length 1. Sigma power 2. The strings of length 2. That means we can draw the any length string from the alphabet power. That is called as powers of an alphabet. It is denoted by sigma power k. That means the set of strings of length k. Sigma power 0 means 0 length strings. Sigma power 1 means 1 length strings. Sigma power 2 means 2 length string. So on, sigma power k means k length strings. Suppose if you take sigma power 0, that means the 0 length string can be represented with a epsilon. Okay, whatever may be the alphabet, if you want to if you are taking sigma power 0, that means 0 length string can be represented with a epsilon. That means epsilon is the only string of length 0. Epsilon is the only string of length 0. If sigma is equal to 0, 1, then sigma power 1, sigma is equal to 0, 1, then sigma power 1 is equal, you can form the length 1 string is 0 and 1. So 0 is the length 1 and 1 is the length 1. Suppose if you take sigma power 2, then you can take the combinations of symbols from the alphabet. That means 0, 0, 0, 1, 1, 0, 1, 1. So these are 4 strings of length 2 from the alphabet sigma. So here, if you take the length 3, that means sigma power 3. So here 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 strings of length 3. So that means the set of all strings over an alphabet sigma is denoted by sigma star. That means whatever the number of strings which you can form from the alphabet sigma. That means from the alphabet sigma you can form infinite number of strings of different sizes, of size 0, of size 1, of size 2, of size 3, of size 4. Like that you can form different number of strings. That means if you have an alphabet sigma 0, 1, how many strings you can form? If anybody asks how many strings you can form infinity strings. Infinity strings you can form from the given alphabet. So of string length 0, of string length 1, of string length 2, of string length 4, like that you can form infinite number of strings. String length 0 means it is sigma power 0. String length 1 means sigma power 1. String length 2 means sigma power 2. Like that, if we combine all these strings, then it gives the infinite strings. So the set of all strings which we can form from sigma is sigma power 0 union sigma power 1 union sigma power 2 union sigma cube and so on. So these are the set of all strings which we can form from the given alphabet sigma is equal to 0, 1. So you can form infinite number of strings of different sizes. So we can show like this, sigma star. That means it is called as clean star, clean closure. We will call it as a, that symbol we will call it as a clean closure. Here sigma star means all strings of different lengths from 0 to infinity. So sigma power 0 union sigma power 1 union sigma square union so on. So the set of all strings or the alphabet can be shown like this. So the 0 length is epsilon, 1 length is 0 and 1, 2 length is 0 0 0 1 1 0 1 1, and similarly this is the 3 length, like that so on. So this is the notation for showing all the strings or the given alphabet sigma, as sigma star is equal to sigma power 0 union sigma power 1 union sigma square so on. The symbol star is called as clean star or clean closure. Clean is a scientist who invented this notation, so that's why it is called as clean star, or you can call it as a clean closure. And it is named after the mathematician and logician Stephen Cole Clean. So that's why the symbol is named with his name, clean star. Here another symbol is called as plus. It is called as positive closure. Positive closure. Positive closure means minimum one time. Minimum one time. That means the length should not be equal to 0. That means the strings shall start with minimum length 1. That means here epsilon is not accepted. Why? Because epsilon is a string of length 0. Epsilon is not accepted. So minimum string means, suppose if you have alphabet sigma is equal to 0 1, what is the minimum length? 1. 1 means 0 1. 2 length means 0 0 0 1 1 0 1 1, like that so on. So here positive closure is represented as sigma plus is equal to the minimum length is 1. That's why sigma power 1 union sigma power 2 union sigma power 3 union so on. So this is what is called the positive closure. The main difference between clean star and positive closure is clean star includes the strings of length 0 also. The positive closure starts at the strings of length 1. So that is the major difference between clean star and positive closure. Suppose if we take clean closure is equal to positive closure union, and if we add the 0 length string also, then it gives a complete clean closure or clean star. So clean star, sigma star is equal to sigma positive closure union epsilon. It will give you, that means here from 1 length strings to remaining strings are there. Only the deficient is 0 length string that we are combining here. So that's why it will be becomes a clean closure. So that is what about a alphabet. So an alphabet is simply a set of symbols which we are using to form a set of strings or a particular language of strings. Now we will discuss what is a string. What is a string? A string is nothing but a finite sequence of symbols from the given alphabet. A string is nothing but a finite sequence of symbols taken from the given alphabet. Let us suppose I have an alphabet sigma is equal to 0 1. From this alphabet I am forming the strings. Let us suppose I have formed, let us suppose S1 is a string. Here 0 1 1. Here 0 1 1 is a string which is framed from the given alphabet. So whatever the symbols are there in the string, those symbols are only from the alphabet. Suppose I have a string S2 1 0 1 1 0 1 1. So this is a string in which all the symbols are taken from the given alphabet. So this is called as string. All strings are infinite. All strings are finite. And every time the length of the string is finite. So a string is a finite sequence of symbols which are taken from the given alphabet. We will form the strings from the given alphabet only. We don't use the symbols which are not there in the alphabet. So please remember that whenever you are framing the strings, every time the strings symbols will be depend upon the given alphabet. Okay, suppose if we have a alphabet sigma is equal to ABC, then AB CB is a string which is framed from the given alphabet. Why? Because A is there in the given alphabet, B is there in the given alphabet, C is there in the given alphabet, again B is there in the given alphabet. So all the symbols in the strings will be there in the given alphabet. Okay. So what is a string? A string is a finite sequence of symbols taken from the given alphabet. Like that, the length of the string is denoted by W. The length of the string. Suppose sigma is equal to A, B, C. I have taken a string S is equal to A, B, B, A, C. So this is the string in which all the sequence of characters or the symbols are taken from the given alphabet. Now the length of the string can be denoted by like this. The length of the string is denoted like this. So the length of the string is 5. The length of the string is 5. That means the number of symbols in the given string is called as the length of the string. What are the number of symbols in the given string? 1, 2, 3, 4, 5. So there are 5 symbols in the given string, so that the length of the string is 5. Suppose if you take S is equal to ABC, here there are 3 characters or 3 symbols in the given string, so that the length of the string is equal to 3. Suppose the string ABCB, here the length is 4. An empty string is denoted by epsilon. So the length of this epsilon is 0. Always the empty string is denoted by epsilon. Is the string consisting of 0 symbols. So the length of the empty string is equal to 0. Always the empty string is denoted by epsilon in entire formal long distance automata theory. So the length of the epsilon is equal to 0. So epsilon means a null string. Epsilon means a string of length 0. We can call an epsilon as a null string or empty string, or we can call epsilon as a string of length 0. That means there are no symbols in the epsilon. So this is what about the length of the string. Now, so when you have strings, you can perform so many operations. We can concatenate the string, we can union, we can perform so many operations on the strings. Suppose if you take operations of the string, concatenation of strings. That means the concatenation of 2 strings is the string formed by writing the first string followed by the second string. We all know that what is a concatenation. Suppose if you have a string S1 is equal to AB. Suppose if you have a string S2 is equal to BAA something B. Now I want to concatenate S1 with S2. I am concatenating S1 with S2. That means first you have to write the S1 string, followed by you have to write the S2 string. So this is what is called the string S1. This is what is called the string S2. So here you have concatenated S1 with string S2. S1 with string S2. This is what is called concatenation. Concatenation of strings. Suppose if you concatenate S2 with S1, you will write like this. First you have to write the S1, S2. What is S2? B, A, B, B. And what is S1? A, B. So you have concatenated the string S2 with S1. So this is what is called concatenation of strings. Suppose here you have a string X 1010101 and another string 4 ones. Then I am concatenating. This is a concatenate symbol. Dot or circle is the concatenated symbol. Concatenation symbol. So here I am concatenating X with Y. Here first I have written X, then followed by Y. So X concatenated with Y. So this is called as concatenate strings. Like that you can concatenate any number of strings. Next one is string reversal. Already we know what is a string reverse. We have already done some programming languages. In that we are reversing the string. That means if you write all the sequence of characters from last to begin in the reverse manner, then it is called as a string reversal. Suppose you have a string S is equal to A B B A. Now here S for R, that means string reversal. Suppose if you write the last character at the first one, A, then A, then B, then B, then A. So here you have reversed the string. That means you have written the characters from last to first in the reverse order. That is called as reversal. So here the string reversal, suppose W is a string, the string reversal can be shown it as a W for R. In formal language and automata theory, most probably we denote the strings with W and the reverse of the string with W for R. So reverse of the string, suppose if you take A, B, C, D, the reverse of the string is D, C, B, A. This is the reverse of the string. Okay, we already know if the string and its reverse are equal, then it is called as a palindrome string. Suppose if W and W for R, that means W and its reverse, if both are same, then the string is called as a palindrome string. So this is about what string reversal. Next one is substring. Substring. A part of the given string is called a substring. A substring is a part of the string. Suppose if we have A, B, C, D. Suppose if we take A, it is a part of the string A, B, C, D. Suppose if we take B, B is a substring of the string A, B, C, D. Suppose if we take AB, AB is a substring of the given string. Suppose if we take BCD, it is a substring of the given string ABCD. So a subpart of the given string is called as substring. Okay, suppose if you take a string A, B, C, D, then epsilon is also a subpart of the substring string. Epsilon is also called as a substring. Suppose if you take A is a substring. If you take B is a substring. C is a substring. D is a substring. Suppose if you take two length, AB is a substring of ABCD. BC is a substring of ABCD. CD is a substring of ABCD. You can take any combination, but the character should come in a sequence. A and D will never be a substring. Why? Because A is here and D is here. Substring means the characters in the sequence shall be continuously there in the given string. Suppose if you take A and D, they are not continuously there in the original string ABCD. Here A is there, here D is there. Never AD will be the substring. Substring means the string should consist of the symbols continuously in the given string. Okay. So this is what is called as a substring. Similarly, a prefix and a suffix of a substring. Suppose A, B, C, D. If you take A is a prefix of the string BCD. Suppose if you take AB is a suffix, a prefix. Suppose if you take ABC is a prefix. So if you go from left to right, you will get prefixes of the string. If you go from right to left, then you will get the suffixes. Epsilon is also a prefix of the given string. Suppose if you take epsilon at the end, it will be a suffix. Suppose if you take D is a suffix. If you take CD is a suffix of the string ABCD. If you take BCD is a suffix of the given string ABCD. So if you take the characters, that means if you take the sequence of characters from start left to right, then that is called as prefix. If you take the sequence of characters, that means substrings from right to left, that is called as a suffix of the given string. That means A prefix of a string is any number of leading symbols of the string. A suffix means any number of trailing symbols of the given string. Leading symbols means from front to last. That means from left to right. Trailing symbol means from right to left. Here A, B, C, D, E. So this is a leading symbol of the entire string. This is AB is a leading symbol of the entire string. ABC is a leading symbol. If you take from left to right, they are called as prefixes. Like that, E is a trailing. E, D, E is a trailing symbols. Similarly, C, D, E, they are the trailing symbols of the string. So they are called as suffixes. So every string have prefixes and suffixes. We can call again a prefixes and suffixes are the substrings of the given string. Similarly, after knowing about the strings term, we should know what is a long ways. Why? Because long ways consisting of set of strings. A string consisting of set of symbols from the given alphabet. Okay. Suppose symbol, the basic elements are symbol. Suppose I have symbols. I have symbols 0, 1. So these are the symbols. Suppose if I keep the symbols in the alphabet, here sigma is equal to 0, 1. So 0, 1 is the alphabet. From this alphabet, I am forming the strings. You can form any number of strings. So from the alphabet, we can form strings. Here, a set of strings. From some alphabet is called long ways. What is a long ways? A long ways means a set of strings formed from the given alphabet is called a long ways. So what is a long ways? A long ways contains a set of strings of a particular pattern or something. We will discuss what is a long ways, what a particular type of long ways. So initially you think that a set of strings is called as a long ways. If you see the definition of a long ways, a formal long ways is a set of strings of symbols from the alphabet. A long ways always we denote with a symbol L. In formal long ways and automata theory, we always denote the long ways by alpha. We denote this long ways as sigma star. You can form any number of strings. Sigma star means all strings of all lengths will come. So the empty set phi and the set consisting of empty string are also long ways. The empty set phi and the set consisting of empty string are also long ways. Suppose if sigma is equal to A, then sigma star is equal to epsilon A of all the lengths. This is a long ways. 0, 1. If you take sigma star, then you can write infinite number of strings. So this is a long ways. If the long ways containing of finite strings, then it is called as a finite long ways. If the long ways contains infinite number of strings, suppose if you take this one, this consisting of infinite number of strings. So this long ways is called as infinite long ways. Similarly, if you take sigma star, here from 0 length to any length you can have. That means you can have any number of strings. That means infinite number of strings are there in sigma star. So the long ways formed with these strings is called as infinite long ways. Finite long ways, infinite long ways. We have two types of long ways: finite long ways, infinite long ways. If there are fixed number of strings in the given long ways, then it is called as finite long ways. If there are infinite number of strings are there in the given long ways, then it is called as infinite long ways. Suppose we will see what is the finite long ways and what is an infinite long ways. We already seen what is the infinite long base? There are no end. All length strings will come into the finite long base. Suppose if I say from the given alphabet 0, 1, form the strings of length 2 only. If I ask you to form the strings of length 2, that means sigma power 2. So what are the strings of length 2? 0, 0, 0, 1, 1, 0, 1, 1. So these are the only strings of length 2. You cannot find more than these strings. How many strings are there? There are total 4 strings. There are total 4 strings of length 2. So we cannot form more than 4 strings of length 2. So here the number of strings are countable. 1, 2, 3, 4. The number of strings are countable. That means finite. So here this is called as finite long base of length 2. You can call this long base as a finite long base. Suppose if I say of length 3, then how you will write? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 1. So here how many strings you have formed? Only 8. That means you are counting the number of strings. That means they are finite. So this long base is called as a finite long base of length 3 on the given alphabet sigma is equal to 0, 1. So already we have seen what is an infinite string, infinite long base. There are no count the number of strings. There are infinite number of strings. That's why it is called as infinite long base. Most of the long bases are infinite long bases. Sometimes you have finite long base also, depending upon the condition on the length of the string. Okay. Now there are some few operations on the long bases. These we will discuss clearly in future videos. But right now, as a fundamental concept, here I am discussing operations on long bases. Union. Suppose L1 is a long base, L2 is a long base, then the union of L1 L2 is denoted by L1 union L2. L1 is a long base, L2 is a long base over the alphabet sigma. Then the union of L1 L2 can be denoted as L1 union L2. Suppose L1, what is L1? Here there are 3 strings in the L1, 0, 0, 1, 0, 1, 1. And the long base L2, 0, 1, 1, 0, 0, 1. Here L1 union L2. That means you are combining. Here 0 will come here, 0, 1, 0, 1, 1. And finally you are combining your L2, 0, 1, 2. This is the long base L1 union L2. That means you can make an operation of union on 2 long bases. Similarly, intersection. If L1 is a long base and L2 is a long base, then the intersection of these long bases is denoted by L1 intersection L2. That means the common strings will come into the L1 intersection L2 long base. Here 0, 0, 1, 0, 1, 1. Here 0, 1. Here 0, 1, 0, 1. These are the 2 common strings in both the long bases. So in the new long base L1 intersection L2 contains only 0, 1. L1 and L2 have only 2 common strings. So that common string will be there in L1 intersection L2. So this is what is called the intersection of 2 long bases. Similarly, next one is complementation. Complementation. Suppose L is a long base over the alphabet sigma. Then the complement of L denoted by L complement. That means L dash. This is called L dash. L complement is the long base containing those strings that are not in L over the alphabet. That means here complement means what strings will come? The strings which are not there in L will come into the complementation. Suppose in our childhood days, we learned some sets like, suppose you have a universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let us suppose this is a universal set. Suppose you have a set A called as 3, 5, 7. So what is A complement? A complement means mu minus A. Universal set minus A. So what will come under A dash A complement? The elements which are not there in the elements of A won't be there in A complement. Suppose if you write A complement, so the elements of A will be cancelled 2, 5 and 7 will be cancelled, and the remaining elements from the mu will be shown in the A complement. So that means the complement language contains the strings that are not in L. That means what are the strings are there in L, those strings won't be there in L dash. That means L dash here is equal to sigma star minus L. Sigma star means all the strings will come minus R. Or what are the strings are there in L, those will be excluded, and remaining strings of sigma star will be shown in L dash. So that is what is called complement. So these are some basic operations of two languages or more than two languages. And the next operation is concatenation. So concatenation means you are combining one language strings with another language strings. L1 concatenated with L2. Concatenation of two languages L1 and L2 is the language L1 circle L2. Concatenation operator is denoted by circle L1 L2. Each element of which is a string formed by combining one string of L1 with another string of L2. Let us suppose here we have BC, BCC, CC. This is the language L1. And CC, CCC is the language L2. Now we are concatenating L1 with L2. First you take the string BC and you are combine the string with BC, CC. So here a new string is, the new concatenated string is BC, CC. Okay. Suppose if you take an example, L1 contains two strings AB, BB, and L2 contains two strings CD and CC. Suppose I am concatenating L1 with L2. So what happens? Suppose you take the first element AB and you concatenate with this element and this element. So what happens? AB and you concatenate with CD, ABCD, comma, AB you are concatenating with CC, ABCC. Similarly, you take another one, BB, and you are concatenating with CD, and take BB and you are concatenating with CC. So these are the four strings after concatenating the language L1 with language L2. So L1 circle L2 means L1 and L2 you are concatenating. So this is the way of concatenating the strings. Next, one more property of strings and language is reversal. If L is a language, then L power R is obtained by reversing the corresponding strings in L. This operation is similar to reversal of a string. Suppose L power R. How you will get L power R? You are reversing each string in the L reverse. If you are reversing each string in the given language, then you will get the reverse of the language. So L power R is equal to W power R such that W is equal to L. Suppose you have a string, you have a language L is equal to 0, 0, 1, 1, 0, 1, 1, 1. Here, if you reverse each string, the reverse of the 0 is 0 only. The reverse of the 0, 1, 1 is 1, 1, 0. The reverse of the string 0, 1, 1, 1 is 1, 1, 1, 0. That means if you reverse each string in the given language, then you will get the reversal language called L power R. Okay. That is what is called reversal of a language. Similarly, the clean closure of a language. The clean closure of a language L is denoted by L star. Already we have seen sigma star. That means all the strings of length 0 to infinity. Like that, here L star. L star can be represented as L star is equal to, or you can call L clean closure is equal to union of I is equal to 0 means 0 length string to I is equal to 0 times means to infinity L power I. L star is equal to union of I is equal to 0 to infinity L power I, where I value changes from 0 to infinity. So this is what is called clean closure. Similarly, positive closure, excluding the empty string, all the remaining set is called as positive closure. So the positive closure L of the long base is denoted by L plus. L plus means positive closure is equal to union of I is equal to 1 to infinity L power I. So this is the way of showing the positive closure. Okay. L star denotes words constructed by concatenating of any number of words from L. L plus means epsilon is excluded. So we are concatenating any number of words from the given long base. That is called as L star. Similarly, if we exclude epsilon and if we combine the remaining strings of any length, then it is called as L plus. So this is called as clean closure and positive closure of a particular long base. In this entire video, we have discussed what is an automata and what are the uses of automata, what are the basic elements required to start the automata theory. Symbol, alphabet, string, long base. These are the four essential concepts which we have discussed in this entire video. So in the next video onwards, we will discuss the complete automatas. Thank you for watching this video. Thank you all. Thank you for watching this video. If you really like this video, please subscribe, like, share, comment on my YouTube channel. In future, we are going to create many more videos on computer science engineering subjects. Thank you.